Hey guys, sorry I got interrupted one more time. But with this information, again, cosine and sine, when we talk about them graphically in our next unit, we'll find that these functions can describe a lot of real-world behavior. So sine and cosine are going to describe things in the real world that reach high peaks and low lows as far as the graph behavior. So we'll see that graphs of sine and cosine can look like this, where you have kind of up and down movement. So things like temperature that can reach high heights and low lows, or financial trends, are going to follow those sorts of graphical pictures. So when we're solving for this information, that's going to come in handy when we do work with our graphs, because we might be interested at when a stock price might hit a certain height, or we might be interested when a temperature reaches a certain low value in the year. So if we can do this kind of equation solving from a theoretical level here, it's going to be a lot easier when we're working with applications in the future. And we'll see a lot of neat applications of the graphs of sine and cosine. Last example, you guys, working with radians is one more tangent operation. So here we are working in radians because we see the 0 to 2 pi, and we want to know where tangent of x is going to give us 0.67. So what angle value has a tangent of 0.67? So that just means we're going to go to our calculator and we input inverse tangent 0.67. When we do that, inverse operation, we get out a radian value of 0.59. So on our circular reference frame graph, remember we're just graphing in radians here, so that's our 0, pi over 2, pi, 3 pi over 2. And when we use our decimal approximations, that's 1.57, 3.14, 4.71, and then 6.28 as our second option there. So graphically, 0.59 is going to look right around here. So that's this angle value. Theta or x equals 0.59. So again, that's our reference angle because that's how long it takes to get back to this x-axis. But this tangent value is positive, so we need to know where else are there positive tangent values. Here, all of our angles are, the result is positive. Here, sine values are positive, tangent's positive, and cosine's positive. So since this is the other region where tangent's positive, we need that reference angle in this quadrant. So we'll take 3.14, because that's our value right here, and we just add our value of 0.59. So that means that term will be 3.14 plus 0.59. And if we plug that into our calculator, 3.14 plus 0.59, we get the term or the value of 3.73. So those are going to be our two answers here. And again, we want to check that in our calculator. So tangent of 0.59 gives me 0.67 rounded. And then tangent of 3.73 in radians also gives me 0.67 rounded. So those are all of my examples. You want to go ahead and use the remainder of class time to work through our homework for tonight. So the homework that you guys have this evening is going to come from two worksheets. So you've got a worksheet 1 and a worksheet 2. The second worksheet only has 4 problems, 8 through 11. The second worksheet, you start at problem number 7 and work through 16, and that's listed on the website. So tomorrow you'll have another practice day so you guys can compare results and notes on the first one, and it will also just put together all of the inverse work. So today this is all calculator based. Tomorrow we'll have a little bit of review on the worksheet, so there will be some inverse work on the unit circle, some inverse work from calculator. And then when we come back together, we'll talk a little bit more about inverse functions, really just because we need to solidify that information as we move forward with our graphs. So please email me if you have any questions on what we're doing, and please welcome our substitute into our classroom. And I will see you guys on Wednesday. Have a great day.